Unit 7 opener number 9 focuses on factoring. There's a lot of different kinds of factoring, but the factoring that this opener requires is factoring out a greatest common factor. Factoring is taking an expression and breaking it up into two factors that multiply to give you the original expression that you started with. If I look at my first expression, 6x plus 3, I need to think about whether or not there's a term that goes evenly into 6x and also goes evenly into 3. And there is something that I can think of. 3 goes evenly into 6x, and it also goes evenly into 3. So I'm going to take 3 and put it out in front. And then to complete my factoring, I'm looking for what I could multiply by 3 in order to end up with my original expression. Basically, I'm doing the distributive property in reverse. So I need to think about what I could distribute the 3 to in order to get 6x. And that would be 2x, because 3 times 2x equals 6x. Plus, then I have to think about what I could distribute the 3 to get 3. Well, 3 times 1 is 3. And then you could always check and make sure that your factoring is correct by doing the distributive property and making sure that you do, in fact, end up with 6x plus 3, which we do. As we move on to part B, we're going to think about this the same exact way. We'll look at all three terms in the expression, 4x squared, 12x, and 16, and come up with something that goes evenly into all three of those terms. Well, 4 is the biggest thing that goes evenly into 4x squared, 12x, and 16. So I'm going to go ahead and put that in front. And then again, we want to think about what am I distributing 4 by in order to end up with my original expression. Another way that you could think about this is dividing every single term in the expression by 4. We're not really dividing by it because the 4 is still there, but doing that will help us to figure out what goes inside the parentheses here. So 4x squared divided by 4 is x squared, plus 12x divided by 4 is 3x, plus 16 divided by 4 is 4. And then again, you can check to see if you're correct by distributing the 4 and making sure that you do get 4x squared plus 12x plus 16, which we do. A lot of times you'll see in the future that the trinomial that you're left with can be factored more, but this time we're in luck, it can't, so we are done factoring as long as we have factored the 4 out of all three of those terms. When I look at part C, 7x squared plus 42, I see that the greatest common factor of 7x squared and 42 is 7. So I'm going to do the same thing again. I'm going to take 7, put it outside the parentheses, and figure out what I can multiply that 7 by to get 7x squared plus 42. Well, 7 times x squared gives me 7x squared, plus 7 times 6 gives me 42. Again, I can distribute and check to make sure that I do in fact get 7x squared plus 42. Finally, part D is similar to all the rest, but it has a little extra piece to it because 9x squared and 63x not only have a number in common, but they also have a variable in common too. So the greatest common factor of 9x squared and 63x is not just 9, which both numbers are divisible by, but it's actually 9x, since both terms have at least one x in it. So I'm going to take 9x, that's my first factor, and then I need to figure out what I can distribute 9x by in order to get 9x squared. Well, that's 9x times x would give me 9x squared, plus 9x times 7 gives me 63x. So we've just factored 4 different expressions. The key to factoring is to look first for a greatest common factor that you can take out of each term in your expression. And then from there, you're just doing the distributive property in reverse to see what factors would multiply to give you your original expression that you started with.